Hey, this is Sam Charrington, host of the TWiML AI podcast, and today I'm coming to you live from the Future Frequency podcast studio at the AWS reInvent conference in Las Vegas. Today I'm joined by Kumar Chellapilla. Kumar is General Manager for Machine Learning and AI Services at AWS. Before we get going, please be sure to take a moment to hit that subscribe button wherever you're listening to today's show. And if you want to check us out here at the studio, you can bounce over to YouTube if that's not where you're listening now. Kumar, welcome to the podcast.
Thanks for having me, Sam.
I'm really excited to chat with you. You were part of the team that announced one of the big machine learning announcements here at reInvent this year, support for geospatial machine learning. We'll be digging into that, but before we do, I'd love to have you share a little bit about your background and how you came into the field.
Definitely, yeah. I've been in the machine learning field for almost 25 years now. I have a PhD in machine learning from the late 90s. Back then, I was on the research side, worked at Microsoft Research for the first 5 years after that. I'm probably best known for my work on training deep neural nets on GPUs from long before deep learning became a thing. But more recently, I've been at AWS for 2.5 years, currently general manager for several machine learning and AI services, quite a few of them SageMaker related. A few years before I came to AWS, I worked on self-driving, the last 4 years before I started. Worked at Uber ATG, which is now part of Aurora, and also Lyft Level 5, which is now part of Toyota. So
Okay.
Super excited to be here.
So you like to stay close to exciting spaces?
I've kind of chased, it's interesting. People say, if you want to do the best physics, you go to the place where the largest colliders. If you want to do machine learning, you follow the data, and wherever companies have the best, latest data, they have the best problems for applying machine learning, and my career has kind of followed that.
Awesome.
With AWS, it's amazing. Like now, rather than building actual solutions and applications, I actually help customers build their solutions and democratize machine learning. And SageMakers are like a great way to do that.
You mentioned that you cover several services. Can you talk about the ones that you're responsible for?
Definitely. Today we announced Geospatial support in SageMaker. Super excited about that. I also manage the human-in-the-loop services in SageMaker. For example, SageMaker Ground Truth is one where folks who want to label data, label data is important for machine learning. 80% of the models built there are built using supervised learning techniques, which require large amounts of label data. So AWS offers, through SageMaker, a data labeling service. I also own some of the DevOps and Code Guru services that allow AI and ML techniques to be applied to improve developer operations, things like increasing availability of your services. Amazon DevOps Guru is the service there. I'm also the GM for Amazon Code Guru, which helps you use machine learning and automated reasoning to find bugs in your code, improve your code quality, and also identify security gaps and recommend fixes and so on.
Okay.
Those are some of the examples.
Is there a method to the madness? It seems like a very broad scope in terms of the diversity of services. Yeah,
so I think the way machine learning works is the applications are persona based. So I'm one of the GMs who, actually I'm the GM that owns services for software engineers and security engineers when they need machine learning and AI. Okay. So you'll see DevOps Guru, you'll see Code Guru, and services in that suite. The other one also, human in the loop, Mechanical Turk is a very well-known service, so that's part of my portfolio. It's the legacy crowd platform for tasking. And then we also have augmented AI, which allows you to combine a human with the AI service. And that way, even if the AI is 80 or 90% there, but your customers need 95 or 98%, you can have that synergy between an AI that does most of the heavy lifting, but then you can back off to a human who can then treat it like a labeling task or even a human task, so that you get the quality you need without having to wait for the AI to mature to meet your customers' quality needs. So I think the human in the loop is the other group. Geospatial is something that I think mapping and geospatial is the other area that are kind of sister areas to that.
Well, let's dig into geospatial. I've been in and around that community for a little bit, not deeply in, but I was at the company that I was at last, did a lot of work with Esri, and we would go to the GeoInt conferences, and there has been attempts to, that community has struggled with the amount of data that has been collected from satellites, and as the sensors multiply and get richer, that those sensors have presented and that data have presented lots of challenges. So I'm curious, like, why now? Why is now the time that AWS is investing in geospatial?
Yeah, so whenever we look at building an AWS service, whether it's for machine learning and AI, you look at where's the undifferentiated heavy lifting. What is stopping the latest GIS expert or the data scientist who wants to work with geospatial data? They really want to solve the ML or the analytics or the AI problem, but in order to get to that problem, a lot of them have to walk through how do I manage my data, how do I process it, how do I get access to it. So on the one side, geospatial data is now become ubiquitous. It's very easy to access high resolution data, even sub-meter level, like 50 centimeter per pixel data is easily accessible. But if you want to access that, there's a large friction to getting access to that data. There's months of negotiation, getting a license, getting that data, and most of them think of it as I need to download the data and then work with it. So with SageMaker Geospatial, one of the things we wanted to take away was, can you with one click in a Jupyter Notebook or SageMaker Studio, can you just get access to the data? And only the data you need. Like San Francisco is 50 square miles of data, not that hard, but with a single click in an area of interest, can you get access to all of San Francisco data? And now you can run your fancy computer vision models or your downstream notebook pre-processing, or combine it with other data, point of interest data. Maybe you have customers who have given you location data, photos with that long information that you want to collate and understand who your closest people are or what are the closest landmarks, bring point of interest data. So that ability to bring that data very easily into a notebook experience, or if you want to push something to production, you want to build a pipeline and you want to make that like a production pipeline on AWS or AWS SageMaker, how do you make that easy? So timing wise, one is unstructured data is growing a lot. It's becoming very easy to access the data, and we just want to unlock that. And just to get a sense of the scale, right? It's not even linear scale. This is exponential. Just 2 years ago, the number of satellites in the sky that were doing things like capturing imagery, or whether it be hyperspectral or even SAR imagery of the surface of the Earth, was just less than 1,000. Now, this year or so early next year, it'll hit 10,000, 8,000 or 9,000. In another 10 years, it'll be at 100,000 satellites.
Oh, wow.
Right, and these are, they're multi-purpose. Cameras are getting so good that within 2 years, the cameras on the satellite go obsolete.
Yeah.
So companies are not even trying to keep them up there. Every 2 years, and the satellites are like little shoeboxes. They're not these monsters that they used to send out that cost millions of dollars. Now they cost tens of thousands, maybe $100,000 to get a little satellite up there. And in 2 years, that thing will slowly come down, and when it won't even hit the ground, it'll just burn out in the atmosphere.
Yeah.
Right, and so you have this capability of sensors everywhere. Right, on the internet we talk about the IoT of revolution, but even in space, that capability is coming. How do you bring all that data in a place where customers can work with it? And you won't believe the scale of data is so large that if somebody wants to work with California data, just all of California, all of a sudden it's like a 10 gigabyte to 10 terabyte image. We're like, I can work with 4 megabytes or 5 megabytes. My iPhone pictures are a few megabytes. I can work with that. You say, oh, we have recognition in AWS. We can run it through. You're looking at a few, like 20 megapixels is already state of the art.
Yeah.
I'm talking about 20 giga to 20 terapixel images. And we're like, oh, but then if it's computer vision, you have a deep learning model, you just scan it all the way across. And we're like, okay, you can do that with a single click or a single API call. Behind the scenes, AWS can say, we'll take care of slicing and dicing it, tiling it, running all your inferences there, and then bringing it back. Or you want to label the same way you do zoom and pan on your favorite mapping app. The whole world is there, but as you zoom into your neighborhood, and so how do you bring that capability in an API that makes it easy for people to? So we kind of try to hide all of that and make it easy for data scientists and GIS experts to work with that.
Awesome. Now 10, 12 years ago in the space, when you wanted satellite data, there were really two major providers that you were, engaging in these negotiations with. Has that aspect of it diversified as well?
Absolutely. I think the number of startups that are doing satellites today is enormous. There's Black Sky, there's IC, and they have 1 or 2 satellites they start with. And they're purpose-built satellites. Previously, these things used to, like Maxar is a well-known company, their satellites are millions of dollars.
Yeah.
Today, you need to invest, and that satellite has to serve for 20, 30 years for you to get value out of that. And launching that satellite is very expensive. Putting anything in geostationary orbit or even low Earth orbit is very expensive. And so those are very hard to do. That has become easier. The number of satellite launches, like if you look at SpaceX, just the ability to move payload into near Earth or geostationary orbits is becoming very accessible.
Mhm.
The other side is the sensor suites. There are satellites built just for detecting methane. NASA is going to launch one, methane sat. GHG sat is a greenhouse gas, the company's name
Wow.
called GHG sat. Their whole purpose is I will set up sensors there for you so that at a certain resolution I can tell you how much methane there is.
Yeah.
And it's like, okay, for sustainability purposes, measuring and sensing is way better than predicting and modeling and all that, right?
Right.
And
right.
once you have that, then you can empower a lot of applications that want that. Hyperspectral is another very big one. The soil, vegetation, they react differently to visible light versus other spectra. So if you want to know moisture in the soil, you don't use light because that's not that useful. You can detect water versus land, but if you want to know whether your soil is dry or what kinds of how much nitrogen there is, those kinds of things you can actually detect with hyperspectral.
Mhm.
And so they're purpose-built satellites for ag tech. Of course, clearly surveillance is another one. People want resolutions, and so to me, that even simple things like supply chain, commercial
Right.
applications where we know last 2 years everybody talks about supply chain, but we're like, okay, where are you getting your information from?
Yeah.
Is there, if I could go to the LA port and count how many container ships are waiting to get
Right,
in,
right.
and they've been sitting
That's
there for
been a
3
big
days?
deal for years now, like counting cars in Walmart to determine, stock, try to predict stock pricing,
Yeah.
stock prices, things like
And
that.
the beauty of containers, there's only 24,000 containers in the whole world, right? And they're somewhere between East Asia and America and Europe. They're moving around. They're huge.
Yeah.
They're like the size of a big bus.
And standardized.
And even at a half a meter pixel resolution, or even like at a meter pixel resolution, they show up as nice tens of pixels by tens of pixels in size. And then they move, but at the satellite images, they move relatively slowly. So you can detect and track all of them. And you can count them.
Yeah.
Some of the resolutions are high enough that you can read the numbers off of these. And so you don't even have to worry about tracking them over time. You can just kind of know how many there are.
Oh, wow.
So, and putting that in the hands of somebody who's a commercial, either somebody who's predicting the economy impact of this, or even predicting the performance of stocks or businesses, financial industries, insurance companies want to know. Super powerful.
So is there something akin to a satellite data marketplace that a developer can just go to at the beginning of this process, identify what offerings are available, and use that as the starting place for building models?
Yeah, so SageMaker Geospatial currently offers a catalog, so you can go in there, there's drop down. So for example, Planet Labs, Foursquare, there are data sets that we currently support. We also support Sentinel-2 and Landsat from Amazon Open Data. So Amazon Open Data is also a large repository of data sets that are publicly available. They're free for anybody to download and use, or use them within SageMaker. So we're starting with the catalog. We want to grow that over time. SageMaker Geospatial is in public preview right now, and so it'll go GA soon. So we'll offer a wide variety of sources.
Both commercial and open?
Yes, both commercial and open. So Amazon Data Exchange has a open data set catalog that's pretty rich. For example, NASA first brings all of their Landsat and Sentinel data to AWS, and we help them process it and we host it, and everybody else who wants that data downloads it from AWS. We'll continue to do that for more open source data sets. We have commercial companies like Foursquare that offer point of interest data here and Esri data sets, and they're also available through Amazon Location Service APIs.
Now, Foursquare is a name that I have not heard in a long time. What are they doing in this space?
They are very good. They're well known for their point of interest data. So,
okay.
and I mean, you probably remember the check-in app.
Check-ins and-
Yeah. Check-ins 10 years ago.
Yep.
It's still, I mean, I think of check-ins as like human curated, highly, what I would call curated data sets, right?
Yeah.
Versus, I mean, I worked at
Somebody
Uber.
said that this is really a bar as opposed to, some.
Yeah, and they check in, right? And you can even have.
So there's a currency to it.
Plus, it's just one dot. So on the back end, it's so easy. Like I worked at Uber and I worked at Lyft, and when you build these ride-sharing apps, you know that for safety and for predicting ETAs and so on, both the driver app and the rider app talk to the services in the cloud all the time, so that you know where the driver is and you know how far you are from your destination, all that stuff. Now, they collect so much data, but if you ask them where was the person picked up, where was the person dropped off, you have to trust whatever they chose, right? If I say I want to be dropped off in Mountain View and I want to be picked up at the airport, you trust that that's what things happen. But you know how humans are. We're like, oh, I got picked up 4 blocks away, or I asked them to drop me off a little bit earlier because
Traffic
I want
or whatever.
exactly
Yeah.
and so whereas here when a person says I checked in, you don't need that whole stretch of data. You can get really high fidelity data. That's one of the benefits.
Okay.
So I think anytime humans curate data, it becomes very powerful. It's almost like label data. I mean, it's still there's noise and humans do make mistakes. But I think
is that data still crowdsourced through check-ins?
yeah, and of course, and they've kind of grown beyond that. I believe today, they also aggregate data from multiple sources just to kind of have a complete data set.
Yeah.
They're best known for their places data. They also do foot traffic data, so they know movement of people. So I think their places API and their foot traffic data is pretty good.
Okay, interesting. So we've talked about use cases in ag, financial services, finance, surveillance. Was there any one of those that was a kind of a standout driver for developing this and offering this service?
There's many verticals, right? We are in public preview, so we wanted to start with things that we were passionate about and that customers really cared about. I think ag tech is one where we've sort of started with ag tech. We also think automotive is important. For example, BMW is using SageMaker Geospatial to decide where to put things like their charging stations. They have information about where their drivers and their customers are driving their cars. Things like today they're gas cars. And so you know where all the gas stations are. And they want to then figure out if I were to understand the driving profile and the driving behavior of my customers, I can offer an EV. And I can also decide where to put the EVs among the customers I'm going after so that they don't ever have to go too far to get their car charged and so on. Right. So automotive is one. The third one is insurance. So a lot of our things around predicting and monitoring forest fires, floods. So insurance companies want to know what is the likelihood of the impact to a property or impact to an asset that they're evaluating from one or more of these geospatial signals that you're looking for.
Okay. So when we're talking about folks developing applications around this type of data, let's dig into some of the challenges that they tend to run into. You've talked a little bit already about this idea of taking away the heavy lifting, and you kind of flew by things that came back to mind to me, like tiling, orthorectification, all these things that you need to do with this data. Talk a little bit about the pain points that you're trying to solve for our customers.
Yeah, so the first one is, I mentioned data access. I think a lot of the data scientists really want to be in the notebook and be able to access the data as if it was from a database or a data frame, which they're used to.
Yeah.
And so that's one. I think the intrinsic thing we want to make very easy is create an experience where they can bring all their data sources in one place so that they can work with a SageMaker Studio or a Jupyter Notebook style environment. The second one is joins. It is surprisingly difficult to join geospatial data because think of something like GPS traces. You take a ride share you get picked up at the airport, you get dropped off at home. You'd think the GPS sensor on your phone is so good that it will give you all the right locations along the way. It doesn't. There's noise there. If you're lucky, it's less than 10 meters. Even the best GPS traces are, they're pretty noisy. So the first thing people want to do is clean up the data.
Okay.
So we offer a map matching service which allows you to take a GPS and say, oh, I would like you to match it with this version of an OSM map. And you can go from several thousand data points to a few dozen data points, which are the intersections and the roads you were at. And that can be a pre-processing engine that'll make it very easy for you to later on reason about things. So that's sort of one direction we were trying to make things easy. The ability to even post-process, people don't want to work with pixels. They start with pixels because that's where the data is, and most of the data providers will give you pixels. And you mentioned some of the low-level signal processing things like orthorectification, and
so that's further upstream than
So we want to enable the cloud removal is one.
Cloud, right?
Yeah,
right.
It's very simple, right? Everybody wants it, and and the question is, I just need to know where I shouldn't care because I can't see the things because of cloud cover, right? But there's deeper and deeper things. The technology for working with geospatial data today, I come from a signal and image processing background before I got into machine learning. My master's was in signal and image processing. And computer vision's come so far in terms of like phones, languages, and text, but that technology hasn't reached the geospatial space. So you can apply object detection, semantic segmentation, but it's still new. There's no ImageNet for geospatial. ImageNet for image classification is 10 years old. AlexNet is 10 years old. It's amazing. It's like a 10th anniversary. And that was one of the pivotal things that brought deep learning and computer vision to the masses. So I think the geospatial revolution of that kind is happening now. Maybe it's already 2 years in, but there's still some ground. And I want to make that easy for people, where bring the best deep learning models and apply it to this data. So I'll give you a simple example. The traditional way of doing geospatial data processing was more around, you had vector data, which is like, let's say, a road network. And you have pixel data, which is satellite imagery. And then you have point of interest data, the Eiffel Tower, Statue of Liberty, your favorite restaurant, whatever. And you would write traditional algorithms, computer science software, and some of them may be AI, where you write heuristics and rules and algorithms to search and so on. And that's how you would operate. Very hard to create a machine that says, if you give me more data and more labels, I can get you a better system. With things like ETA prediction, when will my Uber ride arrive, or when I start taking the Uber ride, how many minutes will it take me to get to my destination? All those things are predictive models, right? Clearly the distance and the locations matter, but there's a lot of data that's coming behind it. In order to make those better and better, you need this data flywheel. Better data, better labels, a better ML model should be iterative in a flywheel sense, get you a better and better model. So that is hard to do with traditional computer science heuristics or even signal processing. So I think by bringing these data sets, there's also a persona change. GIS is the traditional expert. That field is very deep. I have a lot of respect for that. And there's so many human vagaries that are there on the road network. Just complexity of that is mind-boggling. Whereas in the future, I think people will just use large amounts of data, and just like language models, they're going to skirt around. You don't need to know grammar and other things to like break down sentences. You'll just train a huge neural net that's going to train on insane amount of data and just do things for you, right? And so bringing that computer vision technology to these spaces will make it very easy. So traditional things like object detection, semantic segmentation, and the other beautiful thing I like about geospatial, which is not the same as computer vision, is you can take pictures of people all day for 10 years, 100 years. People are going to change. Clothes are going to change. The technology will change. Surface of the Earth does not change that fast, right? And there's like planets
or even cars, if you're trying to identify vehicles top down, there's a finite number of them.
Yeah, and the surface of the Earth is finite, right? Things change, but they don't change that fast. So with every pass of this data on the surface of the Earth, you're almost like getting higher and higher, richer information. Now there's some change, 1 or 2% changes every while. You want to keep up to date with the changes, but it's almost like watching something that over time you're getting more and more information about. So it's going to get very, very good. And so I think when you bring computer vision to that, I think the computer vision models working on geospatial will be way more accurate, and they can bring a lot of value because things don't change as much and things don't change as fast.
We've talked about these 3 different types of data: satellite, mapping, and point of interest. Does someone need to be building an application that uses all 3 to be interested in the SageMaker Geospatial ML? Or if you're just building something around mapping, for example, is it still relevant?
You don't need to. In some cases, you can. There's nothing that limits you.
Don't need to what?
You don't need to combine all 3 for every application. I'll give you an example. Let's say, simple thing. Let's say you're a mapping company. You want to find where the roads have changed. You're looking for changes, but you're not looking for any kind of change. Not where the vegetation is growing. You just want to know where were the new roads paved, and maybe my map has some roads that are no longer around, or with COVID they've shut them down or something. So you need to have a deep neural net. So you can build a deep neural net that extracts roads, and it's just it's a bunch of pixels that it lights up as a mask. You can compare that against your road network, because you can always render a vector data set on a image, and then you can look for differences. And then you can have a human in the loop that just looks at the differences and goes, oh yeah, that's a new highway, we didn't see that. Oh, that old one, okay. So you can update your map using that information. Now here I gave you an example of combining the 2, but you don't have to. A lot of let's say you're an ag tech, you have farms. There's no, people use maps today to navigate. You may not even be close to a road. And so there's no such thing as a road network for farms. But you still have, farms that are
another way to ask the question is, do I have to care about the satellite imagery component for this to be useful, or if I'm just doing stuff based on mapping, is it helping me?
Yes. Yeah. So let's take the example of GPS traces and road networks.
Okay.
You have a data scientist who's sitting on 10 million GPS traces from phones, people, cars, whatever your GPS. They want to clean that data and they want to understand what are the most visited places. And for that, you can use map matching to clean up your data and get it on a registered vector map.
Okay.
And then you can do post-processing there, and that you can use SageMaker Geospatial for. It doesn't have to use pixels.
Okay.
Now, you'll be surprised. If you ask a data scientist today to build an ML model to do something, the first thing they'll do is they'll render that vector graphic into an image, pass it into a convolutional neural net, and build a deep net, because that technology is like the big hammer.
That's the tool on the toolbox.
Yes.
The toolbox, yeah.
If you ask them to create custom features, they're like, the hand-edited hand features is still... I mean, you can still do random forests with XGBoost. Maybe the more veteran machine learning engineer will do it, but the fresh grads are like, how can I fit this into a deep net? Because then I don't have to think.
Yeah.
And it most of the time just works. Yeah.
Awesome.
It's a big hammer, right? Yeah.
Awesome. So we were talking about challenges. We talked about data access and making that easier. We talked about, you were starting to talk about kind of off-the-shelf models. So helping folks with common tasks. What are the tasks that you're currently able to help folks with?
Yeah, so SageMaker is built for builders. And SageMaker Geospatial will allow a data scientist who really wants to carve out their special geospatial ML model from scratch. We'll support that. But there are customers, if you go down to some of the GIS type of customers, or customers who are like, I just want to consume something that's post-processed. One of the things we're sort of releasing is vegetation indices. You want to know, I talked about land classification today, you just want to know what parts have certain properties for land use.
It's like classifying.
It's semantic segmentation.
Forests,
It's exactly.
Productive land, that kind of
Exactly. If somebody's studying vegetation growth over time, they can then run this model and just look at the number of pixels and the map of the pixels over time and say, oh, are the forests shrinking? Are the forests growing? Are the farmland, what is the state of things? And they want to operate at the output layer. Right. So you can think of it as another image map, but it's post-processed. You don't have to go back to the raw pixels. And the raw pixels come in multi-spectrum. There's multiple bands. You may not want to be at that level. So that's one that people are interested in.
So do you think of things like that as pre-processing steps or transformations, or do you think of them as pre-trained models that you're offering folks?
I try to think of them as pre-trained models because in most cases, some of them will be like, I'm happy with it, I'll use it as is. Others are like, oh, it's kind of there, but for my data or for my use case, I want to tune it a bit more. Or can I get a notebook or a solution that I can just then extend from there? So we're still in that SageMaker middle layer in the AI ML stack that we operate, where they're builders, but they aren't your ML engineer or even like I'm going to spend 3 months building infrastructure type of engineer. Right. They're more like, can I quickly get to a model to see how I can build an application and solve a problem? So a lot of analytics workloads also come in that model. So my feeling is that the way to think about it is layered. At the very low level, you want to give them all the power. So they want to work on pixels, we'll give them pixels and the low level primitives. If they want to work on higher levels over time, there's some standard building blocks that are there, and we want to make those available so that if people are okay with something state of the art or even standard in the industry, not research maybe, then they can just build on top of it. So that way they don't need to rebuild things that they're okay or happy with and then build on top of them.
So then we went from data access to this catalog of pre-trained models, but I think jumped over the primitive step. What are some of the primitives that you provide to make it easier for folks that want to roll up their sleeves, but also are lazy, like good engineers are?
So the APIs we're providing at the really low level are closer to computer vision APIs, where you can work with pixels, you can work with vector data in like point of interest data or points and polygons. So think of them as a road network would just be a polygon with enumerable things. And we're also making it easy for them to access data from Amazon Location Services through here or through Esri and so on. So that way they can build a holistic end-to-end app on AWS using both SageMaker Geospatial and Amazon Location Services. So that way anything that you can bring into the notebook or into your pipeline, your machine learning pipeline, you can combine and mix and match those.
Okay.
So two examples maybe to be very concrete. One is the map matching one I mentioned, which is more of an algorithm, but we also have reverse geocoding. Your phone might release a lat long for you. You're like, oh,
Right.
Can you tell me if it's an address,
Right.
if they checked in, or you know it's a location, what's the closest location, what's the closest intersection, what's the closest street? Those reverse geocoding capabilities, that's another primitive we offer.
Okay. Did you announce, you mentioned BMW as a customer. Yeah. What other customer examples were announced? Okay.
I think I would go with that one. I think automotive is very good.
Was there one use case at BMW, or are there multiple?
There were 3 use cases that they were doing. One was building driver profiles by understanding their driving behaviors, and they were using map matching as one of the ways in which they could understand things like, are you an aggressive driver, or are you a driver who likes luxury? And so based on that and their driving styles, they can recommend. Also, if you're close to an area where EVs are becoming more in the vogue, then you may be open to that. So that was one use case. They also wanted to figure out site selection is one where a lot of companies make a decision on the example they give is
superchargers.
Yeah, superchargers is now, it's sort of, interestingly, site selection is exactly the supercharger location solving problem. But also the example they give is, where should I open my next Starbucks? There's so many Starbucks everywhere I need to find. But the beauty of that is that's a pure non-pixel, non-image type of data set where you want population statistics. You want to know traffic statistics. Anytime you think about opening a business, like location, 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 right? Yeah. If you're going to be selling coffee, you want to know that there's a lot of foot traffic around that space. You want to know what the ebb and flow is, and you want to be away from other services. If you're going to open like a luxury store for shopping, you want to know the incomes of that zip code, that neighborhood, and the flow of things. So opening so site selection has that. McDonald's does that too. Like, they need to know where to open the next McDonald's, and they keep doing this. They reclaim locations, they add new locations just to optimize their whole collection of stores that they have.
I vaguely remember a conversation with someone talking about the site selection use case, and they were starting to explore at the time, this was several years ago, reinforcement learning and simulation as approaches. Have you come across overlaps between what folks are doing and what you're doing in geospatial and wanting to apply RL and simulation?
So there's on the simulation is good for, I think there's a set of services that do 3D reconstruction of the world, the digital twins. I think there's some convergence going there. Yeah. Even in computer vision, I spoke a lot about machine learning version of computer vision, but there's also the reconstruction part of computer vision, which is like SLAM algorithms to rebuild 3D models of the world. There's computer vision algorithms, and they're more geometric. They're less about this flywheel of data, machine learning, and I don't care what's happening under the hood. Just get me the best performance you can. These are like generative. So you actually have people who are building just cities to the degree, or you have a assembly line, and they want to rebuild the assembly line to like within centimeters of accuracy. Once you have that, then you can do simulations. So some of the customers want to combine the two, but a lot of the work is in how do you generate that 3D world, and then once you generate the 3D world using some type of geospatial data processing or even geospatial machine learning, you can, for example, one of the things that people want to do is they want to know the building extent. Like, give me the bounding box for the building, and how big is the building, and so on, right? And they want to reconstruct the building from not just satellite imagery, but drone, and even in some cases LiDAR mapping data. But once you build it, then you can ask hard questions like, where should I put my next bridge? Or where should my next highway come, because I'm seeing all this traffic congestion. So then they can do simulations, and a lot of the simulations now scale to like tens, hundreds, even millions of agents that can move, and then you can ask the kinds of questions that are generative, and then think about what problems you want to solve.
Do you see this interacting with some of the emerging work around diffusion models and generative models, large models?
Possibly. So, like I said, it is still early days for geospatial machine learning, and that's one of the things I'm super excited about, which is the tools and the technology and the knowledge in the minds of these data scientists is pretty deep, but they've been applying it to like traditional camera from smartphones and other, even self-driving is more advanced. Bringing that to geospatial will be phenomenal, and to me, that large language models, generative models for geospatial would be pretty cool. Like, it's still early. They're able to generate people's faces, like this person does not exist, right? They're able to generate art of different kinds because they have huge collections of those that have been labeled or semi-labeled, and they've been able to train. There's a ton of geospatial data, but nobody's thought about, hey, can I do super resolution on these images? Or, like I said, cloud cover. You remove the clouds, now you got holes. I would love to see a generative model do that. Or if you see the evolution of a forest over time, deforestation, you want to predict 3-4 years from now, how will that look? So there's a lot of generative capabilities. Plus, people just love synthetic stuff. So if you like to visualize how this area would look if you were built out a certain way, so I think there's room for that. It's still early.
Speaking of synthetic, does synthetic data play into geospatial much at all?
That's where I think we were talking a little bit of. There's geospatial and there's 3D reconstruction, or I think there's simulation.
Kind of adjacent areas.
Yeah, and so I mean, video games are another good example of like the technologies that they're bringing to these 3D reconstruction, the worlds, even the metaverse, if you want to bring that in, is that you can sample from the real world and then build it. It's much easier to just replicate something, and an algorithm can do a ton of that, and then you can have a human artist come in and finish it up versus synthesizing from scratch. Right? So there's some synergies there. Overall, people go back and forth. Mapping is one area where they kind of go back and forth, where when you have sensors like LiDAR combined with aerial and drone, you can then reconstruct a region with a lot of the computer vision ML technology, then go back and make it into a wireframe and put it into all these fancy 3D models, and then run your simulations and so on.
Going back to the kind of target user, do you see this primarily as making the folks that are currently doing this more effective by eliminating heavy lifting, or do you see it more as a kind of democratization play by enabling a broader community of folks to work with geospatial data because now they have better tools?
Very good question, right? So the place where we're starting is to make the lives of data scientists who want to work with geospatial data easy. I think that's what AWS does best. That's what SageMaker is really good at, and we want to bring that to the geospatial community. Now, the second one in my vision is there's geospatial experts, like GIS experts. They're slowly moving to the cloud. That's already happening, right? And they're picking up cloud skills. You have the modern day data scientist who is really well versed in language, vision, and those types of technologies, but they haven't spent much time with geospatial. My vision is that community will merge when it comes to geospatial. There's a lot of domain expertise that GIS folks have, which might or might not be needed when the future data scientists get to it. But there are a lot of tricks in the toolbox for a data scientist that would greatly benefit the GIS experts. And so the merging or the unification or the synergistic combination of those two is my vision for how I want to see where we want to go. So today we're starting with how do we make it easy to access data, which is very hard. You'll be surprised. 80% of work that a data scientist or ML engineer does is just data munging. Getting access to data, not being happy with the quality of the data, cleaning the data, labeling the data. And then once you get the flywheel set up, then it's still the actual amount of time you train and evaluate models, even though that's sort of that part has been hardened quite a bit. Whereas for geospatial, the early parts are still there's a lot of work to do. So my sense is in the early days, I want to make it super easy to access data and work with data in a notebook environment for a data scientist. But then I think I see in 2 to 5 years a convergence between the GIS community and the data science community. I would love for every data scientist to know how to work with geospatial data, and I would love for every GIS expert to learn how to use a notebook and use cloud and just scale out and bring the best of deep learning to their problems.
Awesome. Well, Kumar, thanks so much for taking the time to chat. It's great learning about what you're doing with the geospatial ML.
Thanks, Sam. Really appreciate that conversation. Thanks for
Thank
the
you.
opportunity.